When it comes to DevOps, it is hard to really measure success. How big is our success? How can we measure how our pipeline is running? How can we measure how successful, how many runs have been done since the beginning? When it comes to audit, can we really trace back what happened 2 or 3 years ago? DevOps research and assessment metrics, also known as DORA, define 4 key metrics to measure the maturity of a DevOps pipeline: deployment frequency, lead time for changes, change failure rate, and time to restore services. Can we safely say that after 16 years of implementation in diverse companies, DevOps has really changed the way we build software? DevOps has really impacted our way of thinking forward. Welcome to Canada DevOps Summit 2023. We have one topic here to discuss during this session: how the journey of DevOps and what is the future of DevOps. Evolution from DevOps to platform engineering. What is it? Let's find out. A little bit about me. My name is Kengne. I've worked in various companies as a DevOps engineer, senior DevOps engineer, DevOps manager, companies like Accenture, Deloitte, and Catch Talent. I also work as an SRE to understand the monitoring part and how the application is running in production. I'm based in Ottawa, but completely also in US as well. I have 9 years experience in IT industry, from system admin to DevOps and SRE for my last role. I'm AWS certified. Anything on the platform AWS, I have a little bit of hands-on, and I'm also on LinkedIn. You can connect with me through this link. We have 6 points on our agenda today. The first point is understanding DevOps engineering, evolution of DevOps, the challenges of DevOps, transition to platform engineering, key competency and responsibilities of platform engineer, platform engineering challenges and solution. Let us understand the building block of DevOps. What are the core principles of DevOps? So DevOps is just a bridge to cross or to collaborate between developer and operations. So it's a set of cultural changes that we need in order to collaborate, to facilitate the way we build and deliver software. So on his core principle, we have that collaboration. So we are breaking the communication gap between all the teams. We know that software development life cycle has many steps, and during those steps, many people intervened. So therefore, the collaboration between all those people does matter on how and what is the quality of our software we'll be building. So this is more important than any other aspect of DevOps. So after that, we need to facilitate the collaboration and the tools that are used, and that's where comes automations. So why do we want to automate? We know that when we have a human interaction all the time, we have a probability of getting things modified over time. So we want to make sure that every process that can be automated. For instance, when somebody push code into the repository, what do we want to do? There's nobody to go and click to run the pipeline. So we want to make sure that, okay, when somebody push code, when the code has been approved to go to our main, definitely it should trigger a process known as a continuous integration. On that, we have to make sure that everything is secure. What is a security aspect? So our SaaS is running. So we want to make sure that when the code is going on the main branch, on our repo, we make sure that it's scanned. And that's how we use different tools, open source or commercial, on that aspect. So to make sure that that code that is secure enough to move to the next steps. We also want to make sure that we monitor, we observe what is happening. That's where it comes in, monitoring and observability. We have different tools, such as Datadog, Grafana, Prometheus, to make sure that, okay, all those aspects are taken care of. We want to see what is happening. We want to get a feedback from application, from infrastructure, to know exactly where we stand. We have different tools. So we have a container that is there to make sure that we run our single test in a single unit, which are affecting all other aspects. So we break it down in a single pod, in a single container, run it to make sure that it's there. And the core principle of DevOps is CI/CD, which is linked to automation that we just discussed. So this is the way for us to understand that we have implemented our automation and everything is running smoothly. We can push the code, make a change, and then definitely see the change, how we went directly on our deployment. Also, DevOps needs scriptings and also coding as well, a little bit of skills on that one. Using tools like Bash, Shell, or Python, or other commercial tool out there to script, to understand, to facilitate the collaboration between all the tools is also a part of DevOps. Cloud is the future. Many companies today are going on cloud just to making sure that they have that elasticity. They can turn on a server in a matter of 1 minute. So they can shrink, upscale, downscale, any capability that we need to run any activity to have. And also we have to make sure that that infrastructure is also immutable, meaning that we need to make sure that that is stable. So when we run this today, tomorrow we come back, we run, we have to make sure that it's the same. That's why tools like Terraform comes in practice. CloudFormation or Azure Resource Manager, and also Bicep, which is also Azure, new tools in place to make sure that, okay, everything is in place and nothing has changed. Or if you run, we take this code from production, from development to testing to staging to production, all the infrastructure remain the same. These are the core principles and where DevOps is based on. Let us understand the evolution of DevOps. So we know that DevOps has been around for about 16 years, going to 17 now. But do we really know what are the major changes into this world or in the world of DevOps? So let us get going. So in 2007 in Belgium, Patrick Debois had a meeting called DevOps Day that has a one goal: facilitating the communication between developer and the operation. Because there was also a lot of fight, not physical, but also a fight, rejection or bureaucracy and all this documentation in the industry to making sure, okay, this is going, this and so that is challenging to really practice DevOps. So that was to facilitate the communication between all of us. And that was where DevOps for the first time was born. That was the first time we heard about DevOps. But remember that Agile came in early in 2000 just to break down the way we build software and we communicate in a whole SDLC ecosystem. In 2011, there was another major step. The term continuous integration was also in place, was implemented. That was late, and that was also the major change in DevOps, which is the first part, which is CI. So this is way to understand that, okay, we have automated everything. We have put everything together, and now let's see how it runs. And that's how developers around the world communicate with tools like version control like Git, like sending code anytime, different time zone, and then in the morning or anytime we see how things have evolved, how the code base has merged. And in 2013, we shifted from running server, virtual machine to container. That was when Docker came in. And that was also a major change in terms of DevOps. DevOps changed the way, Docker changed the way we build every single thing. In 2015, DevOps Institute was born to make sure that those who are working in the DevOps have proper training or have been certified or set standard in the industry. In 2016, Kubernetes was released to the public by Google, and this was also a major impact. The way we orchestrate, we used to have Docker Swarm, Docker Compose to run many containers, but there was a need for a single way to orchestrate every single container, and that's where Kubernetes comes in to change that. In 2019, when COVID hit, everybody's supposed to work from home, and therefore, in 2020, many companies embraced DevOps, which are understanding the core principle or the foundation of DevOps. This led to a lot of DevOps role open, a lot of tools out there, and this was also a major change. After 3 years of working from home, we see a major change. Many companies have embraced DevOps. Can we safely say that DevOps is dead or we need change? And in 2021, we still see a big growth. So now, let's see what are the core challenges that DevOps has faced. So we know that DevOps has a new technology, has a new culture, has a new approach of building things. We know that we face a lot of issues depending on the industry we are in. The major one is cultural change. So, I have been doing this for 20 years, I don't need to change it, I'm staying there. That is the thing that we face. I've been doing this for 15 years, I don't want to change it. So I like it the way that it is. That is where the issue comes in. So the blocker are always there to make sure that, okay, we do it the way, no matter how tidy or how hard it is. And how do we measure success? Many companies focus on the application and infrastructure. They do not focus on measuring the DevOps maturity. What are the metrics? Let us remember that DORA has 4 metrics: deployment frequency, lead time for changes, change failure rate, time to restore services. These are the 4 points that a DevOps pipeline should be focused on. When you reach all this, you know that your DevOps maturity level has really improved. Another challenge was change management. So how do we keep up we have a plethora of tools out there when it comes to DevOps. So we don't know which one to use. When you go from project to project, from company to company, you see different tools. So you have to update, you have to reach out, you have to learn new tools. So this is how do we keep up with that? Documentation. Some tools are very good, but they are very poor in documenting. Also, us as a DevOps, do we really document what we do? When something happens, do we really make sure that we address that properly? Do we have a conference page to keep up when something breaks and we fix it? Or how do we implement something? So something that's also a big issue in DevOps. The budget. Some company don't even want to spend a dime on implementing that new concept of DevOps. So also this is a big challenge as well. The quality assurance. So there's no standard when it comes to banking, when it comes to consulting, when it comes to construction, when it comes to mining, when it comes to aviation, when it comes to any other industry, name it. There's no standard tools. So every company, if you have this company, every company has its own tool chain that is hard to really understand or to really have something standardized. And legacy system. We know that some system has been there since the earlier birth of computer, and there's no way to change it. So the code base has gone, so they don't know where it is. So therefore, it's kind of very hard to really understand, to really grab that. So, but it's working, but we don't know how to. That was all languages, COBOL and all this. So there's no way to even to find out somebody to develop that or to really go and grab that. But it's still working. So therefore, it is hard to integrate. So we need a code to really have a CI/CD. We need a code to improve. So that's also a big challenge that DevOps face or has been facing. Now, something new. Platform engineering. What are the skills and responsibilities? So remember the challenges that DevOps have faced. So now we need to abstract one layer of difficulty when it comes to DevOps. This is having somebody to taking care of all the administrative tasks between DevOps and developers. And that is beauty of platform engineering. So platform engineering is an internal tool to serve developers, or an internal platform to serve all the needs of the company. So platform engineer is there to create different platforms. For instance, when a developer join the company, it's okay depending on which tools he's using, Java, Python, backend, frontend. So he has to go out there and download all the open source. If we are using open source, download all those tools, set up his computer, before he start working. Now we say no, that is too complex, that is too much. And there's no standard when it comes that we might have a different version. So we need somebody who has to come in, build the internal platform. Nobody's going outside. When you need something, when you join the company, depending on your role, this is the package that you need. You just go there and download, and then ready, set, go. Period. Also, coming back again to the collaboration, that is a powerful thing. That's how we want to make sure that all this layer, all this foundation that were neglected on DevOps part are really taken care of here. So the collaboration is still going to coexist between developer, DevOps, and platform. So DevOps is now there just to focus on CI/CD. So to gather all those metrics that we are looking for to know the maturity of level of our project. So you need scriptings. You'll be scripting to making sure that everything is done automatically. Automation, of course, container orchestration, cloud management, security and compliance is very important. Now we are in banking industry. What are the compliance that we need here? We are in governmental agency. What are the compliance we need on this service, on this one? So making sure that we embedded that into our platform engineering, so nobody should say, oh, I'm not aware of that. No, everything is already there. We have built our images locally, internally. We have everything is on the platform to take, because all the compliances have been taken care of in one place. Monitoring and observability. We want to monitor how our platform internal is working, how everything is really working internally. And that's how we understand that monitoring is always eye and ear of every single thing we do. And the training and support, we want to make sure that this part also is the platform engineer role. He's responsible for administration of any other tools internally, so he should be able to train other users. And also this will also be a cost saving for our company. We don't need external trainer anymore, because we have one single platform that somebody is there to do that and train other resources, other employees as well. Now, what are the benefits of platform engineering? Oh, security and compliance. So when we have our audit, we are not scared anymore, because everything has been done. We follow all the principles, we follow all the industry standards before we even download any single line of code in our computer, because our platform, our tools were well secure enough and meet all the standards before we get to our computer. Thanks to the platform engineer for that. Scalability. Oh, now that everything has been embedded, improvement is visible. Anything is changing, we can see how things has changed. Time on the market. Well, what is it? Meaning that somebody is coming, onboarding, we cut onboarding time from 2 weeks to 1 day or to 2 days. So we have another 10 days of working. So therefore, the developer is productive. So the software is is ready very, very soon enough, which are wasting time, because it's ready on the day on. The first day, on the day one, is already ready to start working, because everything is there for him to start working. Improve efficiency. So we know that, okay, the quality, the cost and the time embedded together has been improved, because there's no need to go outside and get something. Everything is in place. Consistency and reliability. And that is the point. Why should I use a version 1.0 when my other is using version 1.1? Oh, it's this computer. No, now we have a standard. Everybody follow one standard. The platform is version 1.0.1. Everybody is using that version. No exception. Nothing outside there. Competitive advantage. Yes, of course. We are ready to compete outside, because we have seen things. We have improved our system. We have improved our platform. So there's no need. We have time now to code. We have time now to do everything. Standard. We have too many tools out there, and there's no proper coordination. We should have one tools. Say, okay, this is a banking system. Okay, here's your tools. This is the finance system. Here's your tools. Here's a consulting system. Here's your tool. Here's a petroleum, mining, in education. Every single aspect of our industry should have a set of tools, which not be having plethora of tools out there. So that's the role of platform. So let's move on. But oh yes, we face some challenges. Of course, this will be most challenging. The complexity of configuration. Let's see big firm, very huge one that has employee all over the world, 500,000, 1 million employees. So how do we maintain, how do we build that complexity, complex system that has a lot of tools around? This is also a big challenge that platform engineer will face. Scalability. How does this scale over the time? Do you really taking care of the security aspect? What is the cost? What are the training that we are offering to keep on going? But this can be completely upside down. This can change when we really embrace this platform engineering. And that's how we can approach this. Remember, we do not need, we are already platform engineering, so we already have a DevOps in place. So automation, no matter complex no matter complex the system, our automation can really help us solve that. Orchestration can also help that. So we automate, we orchestrate. This also will save us costs. Continuous training, and the built-in security. We meet our standard. What are the standards for our industry? What are the new law? What has something changed over the time? Or this year, what is happening? What is going to change? We make sure that that is embedded in our platform. So there's nothing out there anymore. We focus internally. Somebody's in now to go out and grab and get and see and centralize everything for us. Now that we have seen all the challenges and all the benefits, can we really say that? Can we truly say that DevOps is dead? Answer me. No, I don't think so. But are we going to a replacement or something else? Let's find out. I will close with this. Mark Van Boskert said this. Platform engineering is a hot topic in modern software development and delivery, with some claiming it is the replacement for DevOps or even declaring that DevOps is dead. But amid the hype, it is important to understand that platform engineering is actually an evolution of infrastructure delivery, not a replacement, built on the core philosophies that underpin DevOps. He says it all. So we have learned a lot from DevOps. So we are implementing that lesson. So we are now, what have we learned after 16 years of DevOps? Now let's put that in practice. All challenges that we face. Now let's say, okay, this is still based on DevOps principle. That is collaboration and culture among all the team. So our software development cycle now will be better off because the principle, the foundation, the core principle are down. And this is how we see the future of DevOps. Ladies and gentlemen, it has been a pleasure talking to you this morning. And thank you for your time. I'm now open for all your questions. And thank you for coming to Canada DevOps Summit 2023. Thank you.